What's up, guys? Welcome back to the channel. This month we're actually sponsoring the VinWiki YouTube channel. We really like supporting members of our community, so we thought it'd be fun to do a project related to that. Everett, what are we working on?
Yeah, we decided we're gonna make a ring inspired by the supercar. We got two iconic materials. We got carbon fiber and titanium.
Yeah, why are these special? Let's start with titanium.
Let me tell you about this titanium.
Alright,
so it is light. It is super light, and that's everything you want in a supercar, but also the heat resistance in this titanium is up to like 1800 degrees or something crazy.
Yeah,
that's Fahrenheit, baby.
Very stable under high temperature, super lightweight, super strong. It's used in a lot of the internal parts of an engine, valve springs, things like that, because it's so robust as a material while it's lightweight. So
super strong,
awesome
and
material.
I could probably do a few spins and flips with this. It's super light, but the tensile strength is out of this world.
And the carbon fiber, it's a very similar story. It's both lightweight and strong, but what's so unique about it is because it's made out of these fibers, you can make it in different ways to get different properties. So if you want it to be very strong in the x-axis, you can align all of the fibers in that way to get strength there. So depending on your application, you can customize the carbon fiber to tailor fit your needs without having a single gram of excess weight on your vehicle. So both of these materials have played a huge role in making what modern supercars are today. So we're going to combine them both into a ring. We're going to do a liner out of the titanium, and then the carbon fiber is going to be exposed on the outside, and we're actually going to electro anodize the titanium, so it's going to have a really cool look to it. And then the carbon fiber on the outside is going to have a really unique wave pattern that you don't normally see in carbon fiber. You're typically used to seeing the 2x2 twill weave pattern, but on the other axis of it, it's got this really awesome wave pattern that looks awesome in jewelry. Anyways, I think that's enough talking. Let's go ahead and start making. Alright, first we're going to get started working on the titanium. You'll see we put a piece of solid round stock into the lathe, and then we're slowly just starting to trim down that outer diameter. We're using tungsten carbide tooling for titanium. It can be a little bit tricky to work with. Titanium can work harden as you work with it, so if you're not using sharp tools and you rub the material, it'll start to harden on you. And this is pretty bad because it causes a negative feedback loop. The harder it gets, the harder it is to cut. And the harder it is to cut, the more you're going to rub it, and the harder it's going to get. So you really don't want to do that. You got to make sure you're using good sharp tooling, you're using the right speeds and feeds, and that you're keeping everything cool with a nice bit of coolant. Now to bore out the inside diameter, we're going to be using a drill bit. This drill has a high percentage of cobalt in it. That essentially makes it very stable under high temperature. That way you can work with titanium and you won't have issues with it work hardening on you. Next, we'll switch over to tungsten carbide cutters and continue to widen out that inside diameter till we have it to the exact size we want. Now for this ring design, we're going to put the titanium on the inside, and I'll explain why. Essentially, the electro anodizing that we put on the titanium is not super robust. So you want to put it on the inside of the ring. That way it's going to be completely protected from any outside abuse, scratches, things like that. That way you'll have a really nice vibrant color that'll last forever as long as you take care of it. Now we've got the ring to size, we need to go ahead and cut it off from the rest of the titanium. So we're going to be measuring out the exact width that we want, and then we'll use a tungsten carbide cutoff tool to slowly cut our way through it and separate it from the rod stock. Now we'll do a little bit of shaping. We want to make this ring as comfortable as possible. So we'll go ahead and use a Dremel and grind that down until it has a really nice comfort finish on it. And you'll notice the titanium's throwing off a ton of sparks. That's just an interesting property of titanium in general. In fact, titanium is often used in fireworks because it has such a bright, vibrant color that it produces when you burn it. It doesn't really have a use for us in jewelry, but it does make the process look pretty cool. Now after that rough sanding, it's time to give it a nice polished finish. So we'll go ahead and use some sandpapers to smooth it out. We start at about 200 grit and then we work our way, especially with titanium, I like to go pretty high on the grits. So we go up to about 3000 and then we finish it up with a green polish at a low RPM.
All right, we're halfway through. I just got the liner finished.
Yeah, this is looking amazing. Time to move on to the carbon fiber. Here's just kind of like a rundown of what it is, how it works. So this is the fabric that it's made out of. You can see here's an individual strand right here. Each of these strands are made up of, depending on the fabric, between usually about 3,000 to 12,000 individual strands in just that little space. So it's a very, very fine fiber. That's what gives it a lot of its strength, is that there's so many of them. So you've got your weave like this and you use epoxy to hold it all together. That's what you use to harden it so that it's not flexible like this. So you can make a thinner plate like this. This is probably made up of about 10 or so layers of carbon fiber, and you just cut out a rectangle of it. Obviously, I'm simplifying the process. It's a lot more advanced than this, and it requires vacuum infusion and things like that. But anyways, you cut out a little rectangle here. You stack up a bunch of the layers if you want to go thicker, like this. Stack up even more. If you want to go even thicker, stack up a bunch more. It's tricky to make carbon thicker than this, but for ring making, we never really need that, so that's convenient for us. So from here, we're going to be taking, here's one of our production ready plates that we use. We're going to be cutting out a blank from this, adding it onto the outside of the ring. And what will be really cool about it is that it will show off a cross weave of the carbon fiber. So you get that wave pattern that I was talking about earlier in the intro. So it should look really nice. Carbon fiber is extremely durable, extremely lightweight. We're going to be pairing it with the titanium. So yeah, there's the rundown. Let's go ahead and get to it. All right, now we're ready to go ahead and cut out our carbon fiber blank. Our process for this is going to be quite a bit different from the titanium. Carbon fiber is completely different. You got to use different tools for it. So we're using our diamond plated hole saws. We actually sell these on our Patrick Adair Supplies website if you're interested in ring making. Essentially, we've got a whole set that goes up in millimeter increments. So we picked out the exact sizes that we needed for this ring. So we start with the smaller diameter first, and then we move up to the larger one to give ourselves that blank. As we're going, we're using plenty of water as coolant. If you don't, you're going to end up destroying the carbon fiber when you overheat it, so we really don't want to do that. The water also evacuates any of the particles from down in where you're drilling and gets it out of the way so that your drilling goes a lot faster. It also has the added benefit of reducing dust. So yes, we are wearing respirators as we cut this, but you really want to be as safe as you can. So the water goes a long way in helping with that. Now back over to the lathe, we need to trim down our carbon fiber piece and get it to the precise measurements we want. Those hole saws do a really good job of cutting out a quick, rough blank shape for us, but they're by no means precise. We need to come back to the lathe and get it exactly how we want. So for this, again, we're going to resort to diamond plated tools. We're going to be using a diamond cutoff disc on our Dremel. Essentially, the diamonds are just a lot more gentle. You're essentially just slowly sanding away the material instead of cutting and ripping away at it. Now over to the arbor press, we're going to go ahead and press fit the carbon fiber over the titanium. You're just using the tension of both materials to hold it together, and I promise you it's a lot stronger of a bond than any adhesive. Now before we electro anodize, we just got to do a little bit of shaping and polishing to the carbon fiber. So back over to the lathe, we're going to be using one of our Patrick Adair Supplies expanding ring mandrels to hold the ring blank in place. You'll notice we put down a layer of electric tape. That's so that we don't scratch or ruin the finish that we just spent so much time applying to the titanium. Now up until this point, we've had to use very different techniques for both the titanium and carbon fiber, but from here on out, they're pretty much the same. We'll just be using the Dremel, some sandpaper, and some polish to get the desired shape and finish that we want. All right, Everett, the ring is looking great.
Thank
We're
you.
ready for our final step, which is going to be the electro anodizing here. The goal here is to make it look like what you'd see on a titanium exhaust kit. So Everett, how are we going to do that?
What we have here is an electrolytic solution, so it allows the electricity to flow freely through the water.
Yes, and we're going to generate the electricity with this power supply, and it has adjustable voltage. That's critical because we need to select a very exact voltage to get the color that we want. Depending on the voltage, you can get a ton of different colors. We're going to go for a really nice blue color. We're going to use these 2 titanium rods. We'll connect the negative to this one and dunk it in here. And then to complete the circuit, what we're going to do is connect the positive over here. We'll stick the ring on the end of it there. And then as we dunk it into the electrolytic bath, it's going to color as we go. Let's go ahead and try that out. First, we're doing a test piece. This is to show you guys the spectrum of colors that's possible with titanium anodizing. So you'll notice we've got our titanium rod in our electrolytic solution, and we're gonna slowly pull it out, all the while slowly turning up the voltage. So in the end, we should be left with the full color spectrum that's possible. Now here you can see this displays it perfectly. On the right, we've got a really nice bronzy golden color that slowly transitions to a deeper dark purple. And then from there, it goes to a really nice vibrant blue. And then from there, the blue turns a little bit lighter. And you can actually get a few more colors out of it if you crank the voltage higher, but the colors get very subdued. They're not vibrant at all. I really don't like the way they look, so we just don't bother with them. All right, now onto the ring. The first step is going to be giving it a thorough wipe down with alcohol and a clean lens wipe. That's to get rid of any residual residue, grease, anything like that. If you have it on there as you anodize it, it's going to permanently engrave it and etch it into the titanium surface, and you obviously really don't want that. Now here you can see our setup. You can see the ring is just dangling in the water, but the titanium rod that it's on is not touching the water at all. That's important because you want the ring itself to be the thing that connects the circuit. That's what will cause it to electro anodize. While we're doing this, I'll give you a really quick explanation of how the anodizing works. Essentially, as the electricity flows through the titanium, you're making a super thin microscopic layer of titanium oxide. And in a way, it kind of works like little tiny microprisms all over the surface of it. So depending on the voltage, you're going to affect the geometry of those prisms. And it's going to bend the light and affect what light can bounce out and how it reflects, how it refracts. And depending on the voltage, you change the geometry of that oxide and it changes the color of it. So it's very fascinating the way the physics of it all works. It's not like aluminum anodizing where you use chemicals and dyes to get the colors. It's literally the titanium oxide itself. Anyway, sorry to rant about that. Hopefully that was interesting to some of you guys. But here we go, the ring is finished. You'll notice on camera we first just etched half the ring. That was just to show you guys an example of how it all works. We slowly cranked up the voltage so you could see the colors come to life in real time. Once we had the desired voltage, we knew we had the color where we wanted it, so we pulled it out, showed it off on camera, and you can see just that sharp contrast of where if there's no water touching the ring, it does nothing to it. So we put it back into the water, we rotated it around, got perfect coverage over the whole thing, wiped it down, and here it is. It looks amazing. The color we went for was not a perfect blue. We wanted to have the slightest little bit of purple in it. So if we want a perfect blue, it's about 26.5 volts. We went for 23.5. So it has the slightest bit of purple in it. I think it looks really great this way. It really reminds me of titanium. It's not just a ring that's colored blue. It's that iconic purpley bluish titanium. I love it. Well, that's the ring. I think it really turned out awesome. This is essentially the ultimate everyday wear ring. We've got 2 extremely lightweight and extremely durable materials. It should make for a ring that'll take years and years of abuse and still look amazing. If you want to order one, of course, we've got them available on the website. We'll have a link to that and anything else I mentioned down in the description below. Thank you guys so much for watching, and thank you, Everett, for all the help with this project. If there's any other ideas you'd like to see us try out, let us know down in those comments. Everett and I read every single one of them. We really appreciate it. Thank you guys for watching. We'll see you next week.